So just to add a little bit to what Roger was saying, basically, you can do it via the scripting console. You can do it via the REST API because the REST API can invoke the scripting console. So you can do a lot via the scripting console, including completely destroying your crawl. All right, I'm going to talk about a little different subject. So I'm going to talk about de-duplication, which I've talked about a lot in the past. There are two ways of doing de-duplication in Heritrix. You can use what the Internet Archive wrote, or you can use what I wrote. And, I'm going to start talking about what I wrote, and I'm going to explain why I like it this way and why I don't go with theirs. So the de-duplicator, it's available on GitHub. Right now, it's sort of in a transition state to match Heritrix 3.3.0, which has a lot of good changes for deduplication, and it now does proper work headers the way we want them, which is all great. Makes the records very good, and you can download and build your own package, and soon you'll be able to just download the package. It has to be installed in Heritrix. And the way this is done is basically you grab the Heritrix bit of it and you just explode it into the Heritrix directory, and it will put all of the necessary jars in the right places, and then the sample configuration file into the jobs directory, and you just start Heritrix and everything's there. It's fairly simple. But you also kind of need to build the index. And the index is so the index is a history, what you've seen before, and you can decide how big that index should be. Is it just going to be the last crawl? Do you want to aggregate multiple crawls? And you can also decide, I'm only going to index certain types of documents. Indexing HTML documents is low value. They change frequently, they're very small, and there's a lot of them. So the value in deduplicating on it is small, and it makes your index much bigger, which obviously means everything runs much slower. So the index, there are 3 required fields. The content digest, obviously, otherwise we don't know when we have a duplicate. The original URL and the original time of capture. These are the only items that are required. It supports a few other fields. But you need only have these, and the digest must be searchable. So right now it's a Lucene index, which may not be the best solution, but it works. Yeah.
Just one question. That means that if you have 2 crawls with different dates, they will be pointing to one result if it's the same?
Yes.
Okay.
So I think I'll get a little bit better to that answer. So the digest must always be indexed. And you can also index on the URL if you want, which allows you to do certain things like if you're recrawling a specific URL and there is a match, you've crawled that exact same URL and gotten that exact same content before, then you want to record the previous instance of that URL as being the duplicate. If you don't index by the URL, if you only index by the hash, the duplicate that you reference will definitely be a duplicate. It will have the same content digest, but you have no guarantee that it will be the same URL, even though you have crawled that URL and gotten that content. So it makes the index a little more complicated, and I'll get to it just a little bit more. So you built this index before you crawl. You can use the crawl log, or you can use your work files, whichever works for you. If you have some other data set, building your own thing to populate the index is fairly simple. And there's a command line tool that comes with the de-duplicator, a few options, and these are mostly just deciding what should be in, what should not be, so you can really tune the size of the index. You want to keep the index as small as you can manage without actually skipping data. Once the index gets into the hundreds of millions, it'll probably start breaking down a bit. So yeah, you said you can use either the work iterator or the crawl log iterator to run through, and you can build up. So if you have multiple crawl logs, you can feed them one after the other to build a deep index. And the way it works is if you're indexing just by hash, each time a hash gets added and it's already in the index, the old one is dropped, so the last one wins. If you have both hash and URL indexed, the combination, so it will only drop if there's a combination, both match. So, but it will still be the last one added wins. So you need to take that into account, whether you take the most recent log or the oldest log, depending on which one you want to win. And if you're running it usually is about the amount of time it takes to rip the works or the log files off of disk. That's the time constraint usually, so it's pretty quick. So this leaves you with an index, a Lucian index, and it leaves you with a little configuration left to do in Heritrix. So let's go to that next. Am I in the wrong? This is not the right file, sorry. Moment. Here we go. So you need to wire, after you install the deduplicator into Heritrix, you need to wire it in, right? And this is a sample of how you could do that. As you'll note, there are two beans. So the first one is the deduplicator. This one is fairly simple, and it has, as you see, I've used the decide rule sequence to decide we're going to accept everything, and then we reject anything that begins with text. And actually, nowadays I would narrow this down to text HTML. We did some data looking at and found that non-HTML text is actually a good candidate for deduplication. And there are a bunch of blog posts about this. If you're interested, I can point out. So this one decides what gets looked up in the index, and if it is deemed a duplicate, this being flags it as such in the way Heritrix understands, so that the work writer will write a revisit record and everything happens. And it uses the second bean to access the index. So the idea here is that we might have different types of indexes in the future, so it wouldn't just be the Lucian index. That's why it's split up. And the most notable here is the index location, so that's just a file path, wherever you put the index, and a search strategy. So that gets us back here. Yes, that's not going to work. Let's do it in code. So search strategy is, so depending on how you've built the index, if you just index the digest, you got to use the digest any. Now that's the simplest one, and as far as I can tell, there's no problem with it, but it feels a little awkward, the fact that you are not taking the same URL when you've crawled the same URL and you've gotten the same content as you did now, but you're going to flag some totally other URL as being the duplicate record. It just seems a little weird, but if you're okay with that, you're okay with having that, able to use the simplest index, use digest any. So it will just look for the same digest. If it finds one, it's cool. You can also decide on what's called URL exact. It will only view exact URL matches as possible duplicates. Even if you have the digest on another URL, it will not match it as a duplicate. So if you, for some reason, you're running an old version of ABAG or something that can't handle it, this is what you do. And you can also, this variant that allows to be the exact URL or the match to the canonical version of the URL, which opens up a little bit. And then there is this sort of bastardized version here. So this one will try to find an exact URL match if it can. But if it can't, it will accept a digest-only match. So it sort of will, if it's any chance of retaining that sort of history, it will do so. But if there isn't, if it's a new URL, but we've already seen the digest, we'll record that. That's I ran it with that. It's more expensive. The index is larger, and this is a much more expensive query. But sort of, it's mostly, I've been thinking about this for the past 6 months, and I can't find a good reason to do this, good engineering reason, but it sort of just feels a little safer. So if you have thoughts on that, I'd love to hear them. So if you've done all of this right, you will run a crawl, and things will get flagged as duplicates. And what happens is that the work file writes a revisit record, and you will get some additional data in the crawl log. So one of the configuration items, and just find that here real quick. Nope, that's not the right one. So the logger module for Heritrix has this little thing called log extra info. What this will do is create a JSON field at the end of the crawl log with a bunch of fields, and it's arbitrary what gets written to it. By default, you'll usually see the work name that the file got written to. So the de-duplicator actually uses this and records information about what URL and timestamps were deemed to be the duplicate. So you can actually see information about why it was deemed a duplicate. So the crawl log has detailed information, not just about the duplicate, but about the original version. So you can actually, from the crawl log, infer where you need to look in order to get an actual record rather than just a revisit record. And that becomes very important because when you're rebuilding your index for the subsequent crawl, when it hits one of the revisit URLs, it can then use this information to populate the index. Because if it didn't have the information about the originals, it would either have to look it up or just skip it altogether. So, or of course, if you're building by the works, that information is there as well. But building from the log is just so much quicker. It's a fraction of the size. That takes place in minutes, whereas the others in hours or days. Any questions so far? So Heritrix does things that's usually a little bit different. So the original version is what they call the fetch history processor. You wire this in after the fetch processor runs, the fetch HTTP, and it does a little magic to keep attached to this URI a history of what has been seen before. So as it goes into the frontier, even if after it's been crawled, a little bit of it will survive. So when you're crawling again later, and that URL comes up again, it's supposed to get populated again. So what this means is that the BDB, the Berkeley DB data structure from one crawl needs to remain intact for a subsequent crawl, otherwise you will not have this data available. Now, there are a number of problems with this, starting with the fact that maybe you forgot to turn this on, but you now kind of want to deduplicate based on your last crawl. The BDB data structure gets corrupted way too easily. And sometimes if you're upgrading to a newer version, the data structure and the newer version just won't match up due to API changes, and you wind up in trouble. There are ways around and dealing with this, but I find just decoupling completely from the Heritrix internals to be much, much easier. There is, though, a new development that I kind of want to point out because it is interesting. So I want the loader first. So it's a pair of processors called the content digest history loader and store. So what this does is it maintains, again, inside the Berkeley DB, but it contains memory of observed content digests. So when this thing runs, it will consult its store and see if it already has this content digest. So, and if so, it does some checking to see if it matches the current one, and if so, dealing with it as a duplicate. And yeah.
I have a stupid question. What's in a content digest?
So content digest, sorry, if the terminology.
Checksum or-
So it's a SHA-1 checksum, SHA-1 digest.
Okay.
So
Of the payload.
of the payload, yes. Just to be absolutely clear, it is always of the payload, not the headers. The headers are not included, just the payload, which means that anything that has a null payload gets the same digest, by the way, which you do not want to actually write as a revisit record. And the revisit records always contain the headers. So it just drops the payload. Yeah, well, there's
They
now.
always contain the headers now.
Now.
So then you parse the content before making the digest.
So the digest is created by the fetch HTTP processor as it downloads off the wire.
So this deduper only works on the fly, you can't do it as a retroactive.
This de-duplication, yes. I mean, obviously, if you're willing to rewrite your works, you can do pretty much anything you like.
Of course, yeah.
But
But this
this-
is designed to work on the fly.
Yes, as you go along.
Yeah.
So it, because most of us don't really like rewriting the works if we can avoid it. It's a little bit taboo. Just to finish this off, you need to pair it up with the storer, which we'll just pull up here. And this one has to run after the work writer process, and it will store information about the content digest. And the reason why it has to be after the work writer is because at that point, all of the information is known. It's been done. But so you need to pair these two up, and it will run. And the good thing about this, and what mine doesn't do, is that if you discover a payload that is identical to something you've already crawled in that exact same crawl, you will deduplicate on that. Whereas mine only will discover duplicates between crawls. It won't discover duplicates that are encountered mid-crawl. So I did a little analysis of the value of how much you can save. It's not much, maybe 5%, depending on the nature of your crawl. But there is a little extra to be had there. So if you're not resource constrained in terms of a crawl, this can save a little extra. But again, you run into the same issues keeping it from crawl to crawl, that the Berkeley DBs are fragile, and all of those problems do remain. You may wind up having to do surgery on the Berkeley DB. So, any other questions on deduplication before I move on?
Do you think that 5% saving is worth it?
Like I said, it depends on your needs. I mean, if storage is tight, but processing power on the crawl server is not, then maybe yes. It's not for me in my environment.
And the worst case scenario then being that you're then breaking the BDB stuff and having to go into
Yeah.
crisis mode as well. I mean, that's part of the cost of it as
Yeah.
well.
Well, actually, you could probably pair this with my de-duplicator and just use this to catch the ones that happen within at crawl time.
Right, okay.
So
So it should deploy cleanly. So it's a storage process of trade-off.
yeah,
Okay.
pretty much.
So for our contract crawls with our current partner, Internet Archive, we dedupe based on MD5 and URI. But we also dedupe based on content digest for YouTube URLs. YouTube has a ton of different URLs for the same content, and there's a huge saving on that. So it just depends on what content you are actually harvesting.
Yes. That's obviously, I mean, the numbers I have of the Icelandic domain crawl, if you're crawling atypical content, the answers may be different. I mean, if you're crawling some, there's one website I encountered, and they have this infuriating thing. They have a few graphs that are on every page, but they put some random nonsense in because they want them to be refreshed. So we get like a gazillion different versions. Well, it's the same thing, but under different URLs. And this would take care of it. But they're so small, and it's just that one site. But if you were just crawling that site, this would save you a ton, relatively speaking. So obviously, it's always understand your crawl. Usually, deduplication becomes more valuable as you crawl more frequently. If you crawl less than once a year, you probably get no value from it, really.
But can you say something about the savings between crawls?
Yes. So, I wonder if I can just pull up. I have a number of blog posts about this. This is not the one I wanted. So this is from our last domain crawl. We crawled a little over 7 terabytes. And like I said, we excluded text documents, so we were only deduplicating on 4.8 terabytes really. The rest wasn't even subjected to it. And we deemed almost 5 terabytes to be duplicates. And most of this data does not compress well. And if we had been doing digest at crawl time, we would have caught another 120 some gigabytes. So it's fairly trivial, which is why we're not going to chase it. It's just not enough. But yeah, as you can see, of what we subject to deduplication, it is 70% or something like that. So there's a lot of savings. We crawl every 4 months, by the way. If we crawled once a year, the numbers would be lower. And we do weekly crawls, and I think we deduplicate on everything there, and we throw away about 90% of the data by volume. So that's.
So the more frequent, the more.
Yeah.
Obviously, the more.
Yeah.
Percentage.
Pretty much. So, which is more or less intuitive. So, how am I on time?
Okay.
Okay. We'll move on to.
About 10 minutes.
I'm going to talk a little bit about writing for Heritrix, writing your own processors, side rules, etc. Sorry.
Just a question. If you're indexing only the content digest and your collections are beginning to be huge, is there a risk to have the same digest for 2 different content?
So, well, you shouldn't. If you find that that's the case, you should probably start. I mean, the odds of a chance collision in SHA-1 is very, very small. Yeah, I forget what it is. It's
The collection are huge, so.
if you actually encounter that, I'd love to hear about it. The thing is, if you encounter it, you may never know about it because how are you going to figure it out?
I'm trying to find a
I think the odds are they're probably in the hundreds of billions.
That's a birthday paradox. But it's
1
not.
in 1 in 10 to the 45.
Yeah.
Oh, okay.
So that's, I mean, SHA-1 is subject.
I mean, MD5 has been cracked.
Yeah, so,
in principle, you could get a malicious, deliberate collision
Yeah.
on MD5. I can't imagine why anyone would do that.
Yeah.
But
You're not
it's
using it
possible.
for crypto, so that doesn't, it's only,
Exactly.
it's cracked for crypto, it's not cracked for
Yeah.
fingerprinting, which is what
Yeah.
we do.
Yeah.
I mean, if somebody really wants to mess with you, it's theoretically maybe, but we're not assuming a malicious intent, so it would be chance. And 2 to the 45th is a very large number.
10 to the 45th.
10 to the 45th. Oh, sorry, that's an even larger number.
That's a lot of zeros.
That's a lot of zeros.
So,
Yeah, I think that's like more than stars in the universe. So,
Have more chance to win the lottery.
significantly.
every day for your entire life and your children's lives.
Yes. The chances of winning a lottery is usually 10 to the 8th or 9th. So, yes. All right, let's move on. So, when you're writing your own modules, and there are so many reasons to write your own modules. Usually, it's like it doesn't quite do what you want, so you want to fork one of them. We talked a little bit about scoping, and one of the modules that you will use a lot during scoping, if I can find it here, is this one, the matches regex decide rule, which has the distinction of having been one of the decide rules I made up. It's a list of regular expressions, and as you can see, there isn't a. Wait, am I in the wrong place? Yeah, sorry. This was the one I wanted to be in. As you can see, there isn't a list here of regular expressions as you'd usually found, because I got really sick and tired of having to escape the ampersand, because I kept forgetting. And I wanted this in a config file, but Heritrix doesn't let me put it in a config file. So I forked it, and I put in enough. So instead of pulling it from the CXML, it now pulls it in from one of these config files. This is just, as we saw this morning, it's used elsewhere in Heritrix, so I was able to use all of Heritrix's plumbing. But now it pulls it from this little list. And so I'm just going to pull it up. And really, if you look at it and compare it with the original matches list regex decide rule, it looks very, very similar. The only real difference is that it now has this bit here, which lets me set the source. And it has one little change, if I can find it. So I hook into the application event. So this is old Spring stuff, so application events get fired for all sorts of things. And I look at which type of event it is. I'm not interested in the crawl state events. If it's not, I'm only interested in crawl state events, sorry. And then I check, and I'm only interested in the preparing. So this is an event that happens when you click build a job, not launch, just build it. Gets fired out to all of the beans. And when that happens, import the regexes. And there's a method further down that then just pulls this source and dumps everything into it. It's not much code, but it made my life so much easier, because now instead of that, I have this much nicer, cleaner file that is plain text, and each regex can just be expressed the way it's supposed to be. No escaping anything. And I even put in just a little bit of extra code so that a hash at the start of a line would represent a comment. But that was just a little nicety for myself. So there's a little bit of plumbing, and if you want to do this. So you'll notice I have here something project, basically, that I call our Heritrix add-ons. And if you're not at all familiar with Java or Maven, this is not going to be all that illuminating, but if you've worked with it a little bit, you should see that this is fairly simple. So this is a basic Maven project. It's built against Java 1.6 because Heritrix is built against Java 1.6. That's the only reason. It gets packaged into a jar, and this is a jar that you're going to have to put in Heritrix's lib directory. And then it just pulls in Heritrix. It also pulls in a de-duplicator, but that's purely for my benefit. And as you'll notice, they get flagged as provided. So because when we deploy it into Heritrix, it will be there, all of these classes. But this lets Eclipse or any other development environment pick up on the fact that it's there, and when Maven builds it, it will reference all of these. And we're currently building against, all right, that's actually in another file. So if you do this right, like this, the environment will understand it, and what's more, you can do a fairly simple way of running Heritrix in Eclipse. In the wrong place. I'm sorry, I don't have everything set up correctly here to just show, but you can essentially set the Heritrix main class as the run class, and it will pull everything, and it makes it for very easy development. And this lets you tinker with just about everything. And the truth is, sometimes you have use cases where nothing short of tinkering with Heritrix's internals is going to do the trick.
I mean, rebuilding it, changing the code.
Yeah, so one of the good thing about the way this does is that it doesn't actually fork Heritrix. So the other way of going about it is to download the Heritrix project and mess directly with it. But then you run into a problem when they release a new version or do things, because maybe they've added the same class as you did and keeping things in. By having it in this separate project, you are a little bit divorced from it, shall we say. You have this separation. So because I declare in the project which version of Heritrix it's built against. And then if I change that, so right now it's actually a version of Heritrix that, no, that's why things aren't working, it's available here. So this is a version of Heritrix that we built at the Library of Iceland. And it's sort of a freeze in time with a few bug fixes thrown in. Yeah. And what you can also do, and what we do, is if you want to further use Maven, Maven lets you do, and anyone who's interested in this, just let me know. We're happy to share. So this is a build file, essentially. And what it does is it downloads Heritrix, it explodes it, it downloads my add-ons and the de-duplicator and a few other things, explodes those into all of the right places in Heritrix, and then bundles it all up and puts it into our repository. And I can even do a version tag on it. So when I'm doing another domain crawl, I can actually release our own version of Heritrix, all bundled up and ready and stored into our internal system. And we bake into this using the assembly plugin. I don't know if any of you used Maven's assembly plugin, but it lets you bundle in things, so all of our profiles get bundled in as well. So this makes it really easy. Once you've set it up, you basically have a turnkey solution. You edit your profiles, and you just build the environment, and everything gets shipped off. And then we have cron jobs like Roger was showing you that can pull from our repository the latest version of Heritrix, knowing that all of the latest profiles are available, launching the jobs with the correct profile names. And yeah, it lets you do these things sort of from the center. I'm just going to show.
Just
Sorry?
leave your stuff in do you have a public repository for any of this stuff? Or
It's a private.
source stuff?
It's private. Yes. Internal. We're using Artifactory for that. And if you aren't using it, I do recommend. We are considering, so we released, the version of Heritage you saw was released internally only, but we may decide to push that into a public repo next time we do it, just because Internet Archive is so lazy about publishing released versions. So if we put in the effort of getting what we call a stable release, might as well share. But yeah, I don't know, which versions of Heritage are people, who's on 3.3? Yeah, 3.2? Other 3 versions? So
We're
yeah,
still on 1.14, but if we do go, we might as well go all the way to the top if we do go to 3. So
yes. So if you're not using, so I just want to point out that if you're going to go to version 3, going to 3.3 you may as well. There's so many changes. It's a little bit of the Wild West, but the version that we have and is stable is available in our GitHub account. So I can just pull that up real quick.
Why would you recommend the Wild West version?
Sorry, because there have been changes and you're just going to wind up having to redo configurations. The version that we have, oh, it's Heritage 3, right? That we have put here and is in a branch called LBS 2.14.03 is, as far as we know, pretty stable. Yes, Jim?
Did you build on 3.2, your 3.3, or did you build on IA's 3.3, your 3.3?
That's IA's 3.3.
Okay.
So this is essentially 3.30 from about 3 months ago, with a few bug fixes that we knew about that hadn't yet gotten incorporated. I think most of them have been incorporated at this point, but they may have broken other things. So we know this to be, I mean, we ran a full domain crawl with this, encountering no significant problems. So if you want to pull this, this is sort of a, should be stable. There's always the chance that you're using different code paths, that you've configured something differently and are tripping over things that we don't. But you know, we're happy to at least say that this one has been subjected. We did like 3 test crawls before we were happy that we rooted out all of the problems. And if you find, and please, if you do find problems when you're crawling on the bleeding edge, report them loudly. I mean, they don't always hear you. If you just go into the mailing list, oh, I had this problem, and it gets ignored. You need to, yeah.
But how do you validate the results?
Well, that's a good question. It's actually too good a question. What we do is that when we run the test crawl, we're looking for abnormalities in the crawl log. So one of the obvious things is if you're getting negative status codes, there are too many. So from past crawls, you know what to expect. If there's suddenly much more of them, there's a problem. And that's really what it all boils down to. You're looking at various crawl metrics and comparing them to past crawls and seeing if they line up sort of within expected tolerances. And I'll admit, if you've never crawled before, that's not easy because you don't know what to expect. But there are also a few logs. The frustrating thing is there are a number of exceptions being thrown that are just meaningless. They just happen. They hurt nothing. They're due to bad input, and the crawler really should just quietly ignore them, but it doesn't. So sometimes the important errors, the ones that you really need to pay attention to, are buried in. And then, yeah, so that. Other questions on this line? So if I still have time, I want to show just a couple of other examples of where we've decided we didn't like what was available already. Yes. Right. It's here. So when you're deciding which queue things, and I talked about this a little bit, deciding which queue things go on is usually, you usually use this thing, which is called the Cert Authority Queue Assignment Policy. That's the original one. So I added the one with limits. And so this is all about narrowing down the number. So if you have a host name that has a lot of domains, dots in them, usually each one of those subdomains gets its own queue, which is great most of the time. But when you have something like a blog site where every user gets his own virtual subdomain, you have 20,000 hosts on single server, essentially, and you completely hammer that server if you don't do something. And this was our solution. So the limit is the number of subdomains that will be allowed to form the queue name. By default, it's unlimited. But if you set it to 1, it would only be the top level domain. So com, is, etc. If you set it to 2, it would be example.com, but any subdomain under there would just get compressed into that queue. And you could set it to 3 or 4, whatever. I mean, if you're doing it here where they have .co.uk, setting it to 2 would just, I don't know how many domains they have at that level, but it wouldn't be that many. So you'd probably want more like 3. And we use sheets to decide which domains get this. And this is, again, very simple. It extends the original, and there's a little code here for setting the limit. And then we just hook into the main method, which is a get the core key. And we use the underlying method to do, so we run the parent version, and then run it through this limit, which obviously is only applied if necessary, and there's a bit of code here just to pare it down, which is not really germane. But this is just like, there was no other way of accomplishing this. I needed this so very badly because those domains wouldn't let us crawl them unless we did something along these lines. So what I did in Heritrix 1, for individual for each one of those domains, there's you could overwrite, and you could just type in the queue name. But that really meant that I'd have to create a sheet and sheet association for each one of these domains, which just seemed like so much hassle. And this way, I just have one, and I just list them all, which is much nicer. And then the de-duplicator is obviously just add-ons for Heritrix as well. And it's a typical processor. So processors are sort of the basic element in Heritrix. And there's a base class called processor that takes care of integrating with the environment. So you really only need to consider one thing. So there's a lot of here of analysis. There's a method if you want to, this gets run beforehand. If you want to narrow down when it runs, you can skip that method, it won't do anything. The only method that really matters is this, inner process result. You override this and you do whatever you want to do. In this instance, as we've talked about, it just picks it up and decides if it's a duplicate or not. And Heritrix is all, the core unit in Heritrix is the crawl URI. Crawl URI is an object that contains all of the information about the kernel that's being processed. It knows its history, its future. If it's been crawled, it has access to the full. Apparently, there's a big B somewhere. It has access.
I'm angry.
Yes. So it has access to the full payload, all the headers, everything, and you can mess with it as you please. And as we can see here, we get the URL and content digest string. You can also get the raw bytes if you like. We run that through a bunch of things, and then we actually do operations on the query. So usually the way you affect the crawl is by doing operations on the query. And we do this by set the revisit profile, which we will have built up. This is only if this is deemed a duplicate. If it isn't deemed a duplicate, then we just, all right, nothing happens. And annotations, and here's the extra info that I was talking about earlier. It gets written, and so it will appear in the crawl logs. And obviously a process doesn't actually have to change the query at all. If you just want to have something that triggers off of the fact that an URL passed through, maybe it does a little logging or something, you can do that and then we'll just pass happily along. Just have to remember, this is multi-threaded. Just keep that in mind. So if there is something that needs synchronization, I ran into a problem with this. As you'll note, all of these statistics use atomic longs, because I realized if I just use longs, I had the chance that if two updates would collide and I'd only get a +1 instead of both pluses. So you need to be aware that this is multi-threaded. All right, that's all I had. If there are any questions.
I've always just kind of strikes me a bit kind of future looking about the collections. Have you ever given researchers WARC files or ARC files as a set of assets? So they want a bunch of sites and you've got actually you can just have all of the WARCs, or do you only provide access via a resolved URL via a wayback or anything like that?
We have researchers have gotten access to our crawl data, but given correct circumstances, we might hand it over like that. But they've requested more narrow sets than that. Yeah. Notably, they just wanted textual data.
So my question then is then when you've deduped, you presumably then end up with just a placeholder for the pointer for the original.
Yeah. So I get where you're going. So
yeah.
No, what we do. So what we were asked to was for data for a linguistic data corpus, and wanted all of the text. Yeah. So when we hit a revisit record, we resolved it.
Before you give them the.
Yeah. So we and they wanted for one crawl. They didn't want for multi-crawl. So every revisit record got resolved, and we put in the text of the original.
Did you get a feel for what the overhead of that was like as well?
It was modest because we don't really deduplicate much on HTML, and that's the bulk of the text.
Because that then.
But it could be significant.
It will eat into that 5% kind of headroom.
Yeah. So you wind up with if you do it. Resolving these revisit records is expensive because you have to hit a big index.
Yeah, and then pull back a big binary object.
Yeah, I mean that's neither here nor there. It's looking up the index is expensive.
I didn't get into it in my presentation, but there's a lot of complexity in my code base about re-inflating or de-inflating duplicates when you do the full text indexing.
Right.
And getting that right.
Yes.
It's quite nasty. It's still not resolved actually in code base until I get to it.
Okay. Interesting. Thank you.
All right. Anything else?
A more general question for somebody who will start to use Heritrix version 3. Which version would you suggest?
I think if you're just starting, let's just you could start with the version that we have known as stable, or you could just go straight for the most recent. So
but you said that most recent is not public yet.
Yeah. So the most recent version of Heritrix to be released properly is 3.2, and there are a couple of nasty little bugs in it. So I can't use it. So you have the option. You can use this version that we've tagged, which is special version. You can build it yourself pretty easily. But if you don't feel like doing that, then going to the current head of the development is also a valid choice. I don't think they've done anything. So I keep track of Heritrix commits. And in the last 3 months, there hasn't been much activity. So I think the current head is pretty stable overall.
And what about documentation? Is it any good?
No. It's not horrid, but as long as you're just doing things within sort of the commonest line of action, just tinkering with the most common elements, you'll usually find reasonable documentation. But there's also, I mean, you know, just like things, if you want to run it under Java 8, you're going to find a hell of a lot of trouble because Java 8 changed accessibility to the generating ad hoc certificates, the key tool, I think it's called. So just that, you know, it took me 2 hours to figure out why I couldn't get it run into Java 8, just because it changed. I blogged about it, yeah, the key tool. So there are all sorts of little hidden gotchas here and there.
To me, it feels like somewhere after 3, there was a bit of a push to do documentation, and that's
Yeah.
what's on the Internet Archive site. But it hasn't necessarily kept
Yeah.
up with what's changed since then. And there's been some API changes and stuff like that. So it's a little bit dated.
Yeah.
What's available.
I keep running into one of your posts that says you must use this version of Heritrix 3.something every time I go to install it. And I always come across a blog post, and you put somewhere a comment that's like, I run into an issue, use this one.
Yes.
I always go, it's exactly the same route every time. I'll go for the, I think it was 3.2, when it was 3.2, and then there was something about, it was zip stuff, I think it was. And I always just remember that my deployment path is always, doesn't work, rummage around, oh, there's Andy's post that tells me that I'm using it.
Yeah, that was due to a change. I think it was in Java 8 or 7, I forget. But they changed at some point how Java handles gzip. So there was basically a bug in it before that we worked around.
Yeah.
And so they fixed the bug, and then our workaround became a bug itself. So yeah, there are those sorts of things. Yeah, I remember
I'll
it.
go back and check that.
I think it was actually in one of the later Java 7. It wasn't.
It was Java 6.
Was it even in Java 6?
A while ago, it was, yeah.
It was a while
wee
ago.
But I still stumbled across it.
It's actually
Was
yeah.
that not about Wayback?
Oh, maybe it was,
I
maybe
think
I'm wrong.
Wayback was really
I'm
weird.
conflating.
1.6 it did work, 1.7
Yeah.
it didn't,
It's
1.8
not
it did. Or something, there was some weird thing. Yeah, it wasn't ours way back that had that.
Yeah.
I'm not saying
roughly the same.
yeah, because it's kind of in the commons area and that
Yeah.
stuff. So
Yeah, it may have affected both actually.
it probably did. I don't remember.
Yeah, it was one of those annoying little. Right now, if you're using Java 7 latest version or even Java 8 and the latest Heritrix snapshot, none of these types of bugs are, but there are bugs in Heritrix in general, probably. But at the moment, there are none that I'm aware of, or that I'm specifically chasing.
So which version do you use?
Sorry?
Which version do you use?
So we use, like I said, near to the.
No, I mean the Java. When you
Oh, Java. For Heritrix, Java 8.
Java, okay.
Yes. Open Wayback is still on Java 7.
Yeah, but how did you go about it? Because you said there was.
Yeah, there's a problem. It's all documented in this blog
Okay.
post. I'm not gonna. It's boring, but
Yeah.
basically you have to create your own certificate for the HTTPS connection.
All right.
So
So it's Oracle Java 8.
yeah, so they changed the access to the key tool for. So Heritage used to be able to hook into this, but it was in one of the Sun domain namespaces, and so Oracle changed it and said that. And going back in Java 9, there will be no access to it from Java programs, so it needs to be fixed somehow. I don't know. We can, if you already have a cert lying around, you can just copy it over. I wound up solving it by just running it under Java 7, so it created it and then just keeping it around. That was, there are a number of, yeah, if you're interested in that, this blog post is it has all the details. But you can also, and maybe you should, you can put in your own proper cert, so you don't always have to ignore those browser security warnings.